All right, in this video, we're going to talk about how to solve using the quadratic formula. So as long as you have a quadratic function that is set equal to 0, you must have it set equal to 0. Doesn't work if this is a constant. If it is a constant, like 7, subtract 7. That way this c value will change. This will be a 0. It has to be set equal to 0. Once this is set equal to 0, you can just use this formula, plug in your b, your B, your A, your C, and your A into these spots. Run that formula through your calculator or simplify it on paper before putting it in, and you will find your 2 answers for x. Notice there's 2 answers because plus the square root and minus the square root. Those are 2 separate pieces. So set the quadratic equal to 0, then plug in the values. There will be 2 answers. So let's try it out. When I have x squared plus 4x plus 10 equals 7. Again, when this is not 0, subtract the 7 from both sides. Now it is set equal to 0. Big difference here. You must have this as 0. Once this is set equal to 0, this should also be green, by the way. The reason I do that is just to show you there's 2 variable spots, so I can't just kind of work through everything and kind of get this x alone. There's 2 x spots, so we can't get it alone by our regular methods. We have to try different things to get this x isolated. So instead of completing the square or factoring or what have you, because nothing's really gonna, there aren't always options that'll work here, plug it into your quadratic formula. So negative b, here's my b. 4 goes here and here. A is kind of hidden here. We have an a value of 1, so 1 would have to go here and here. C is 3, so all I'm doing is plugging in my a, b, and c into these spots. Now I need to simplify. From this version, negative 4, just negative 4. 4 squared is 16. Over here, 4 times 1 times 3. 4 times 1 is 4, times 3 is 12. So 16 minus 12 goes underneath the square root. 2 times 1 is just 2. Simplifying some more, 16 minus 12 is 4. So I have negative 4 plus or minus the square root of 4 all over 2. Square root of 4 is just 2, so negative 4 plus or minus 2 over 2. At this point, you have 2 options. Okay, because we could find an actual square root, we can't always. Like if this was square root of 5, we wouldn't be able to do both options. I'll show you both, but we wouldn't be able to do both. Because we had this square root, you can go like this. Negative 4 plus 2 is negative 2. Negative 2 goes on top, still over 2. Negative 4 minus 2 is negative 6, all over 2. I can get it to this form and then simplify. Negative 2 divided by 2 is negative 1. Negative 6 divided by 2 is negative 3. That's one option to find my 2 x values. So this should actually say x equals negative 1 or negative 3. Or you can put the big comma in between them. The other option is, once I have it here, I can simplify individually. Negative 4 over 2 is negative 2. 2 over 2 is 1. So, negative 2 plus or minus 1. All I did was divide each of these separately by the 2. It's kind of like distributing, how you distribute and you multiply each of those. You can distribute your dividing as long as you distribute to each piece separately. So, negative 4 over 2, negative 2, 2 over 2, 1, negative 2 plus 1 is negative 1, negative 2 minus 1 is negative 3. 2 different options, 2 different ways to get here. Again, if this was like a root 5 and we couldn't do this, we couldn't simplify it, on your calculator you just type negative 4 plus the square root of 5 Take that answer, divide it by 2. Then do the same thing using minus. We're going to go over an example of what that might look like. So, same thing. And again, this x should be green. Just again, because I'm trying to show you, you've got a variable in 2 spots. So we can't just say, oh, minus the 7, add the 8, and work from there. We can't necessarily do that. We don't know what our x value is, so we can't say, oh, just divide by x or something like that, because then we might be dividing by 0, which you can't do. So our options, we can use our quadratic formula, just plug everything in. If you plug in -8 for your b values, notice this would be a negative -8. Negative negative would make a positive. So in our next one, you'll see that this should be a positive 8. Again, -8 goes in here. -8 squared, negative times negative, is a positive. You'll see that this becomes positive. Again, we just plug in a is 2, c is 7, so 4 times 2 times 7. And a is 2, so 2 times 2. As you simplify this piece, this equation, it becomes positive 8. -8 squared is positive 64. 4 times 2 is 8. 8 times 7 is 56, so minus 56. And 2 times 2 is 4. Simplify it some more. 64 minus 56 is 8. So we're left with 8 plus or minus the square root of 8 all over 4. Now again, we don't know the square root of 8. So we can't simplify that from here. But we can write it in our calculators. I'm going to extend this a little bit so you can see. 8 plus the square root of 8 all over 4. I'm going to start with 8. I always put extra parentheses around it because in case this is negative, I'm saying just this piece plus the square root of 8. Put a set of parentheses around those. This in the red parentheses is my numerator. That's everything on top. Divided by, here is my denominator, 4. Again, I use the parentheses in case this is negative just to say this chunk alone. All of this divided by all of this. The other option in my calculator, I do the same exact thing with a minus. 2 different things give me my 2 different answers. I type it in and round to the nearest thousandth. X is either 2.7071 or 1.2929. Again, this one gives me this one gives me this. 2 different options for my x value. So, why are there always 2 answers? I think this should technically be an R. Good thing I'm not an English teacher. Why are there always 2 answers? Yes, that sounds better, I think. If we have this form, ax squared plus bx plus c equals y. Remember, this is a standard form of our quadratic equation. It would graph a parabola, something like this. Let's pretend, though, that I set it equal to 0. That's the same as saying my y value equals 0. Where is my y value? 0. Well, your y values are 0 anywhere along this x-axis. This is where you have all of the 0 values for y. If you were to put a point at any one of these spots, your y value is 0. Notice there are 2 spots on this parabola where the y value is 0. This is why we always have 2 answers. If you look at it from this standpoint, why are there always 2 answers? Because there's a plus and a minus the square root. So again, from the equation way, it should make sense that plus a square root and minus a square root should give us 2 different answers. From the graph way, when y is 0, here and here, those are our 2 answers. Now, this piece under the square root is kind of what determines that. This is called the discriminant. It discriminates, I know that sounds bad, but it discriminates our different kinds of functions. Now, you might think, well, all of these parabolas are going to touch twice, right? Doesn't it just make sense to have only the one? Well, not quite. Let's think about it. if this square root is a positive number, like 16, the square root of 16 is either positive or negative 4. Positive 4, negative 4. There's two different versions. If this discriminant was 0, if it came out to this squared minus 4ac equals 0, square root of 0 is just 0. There's no positive and negative form. So really, there wouldn't be two spots, there would just be the one spot. And if this discriminant came out to a negative, it would look something like this. What does the discriminant tell us? Well, when your discriminant is positive, again, that's where we have two x-intercepts. We call these zeros. A zero of a function is its x-intercept. We would say there are two real zeros here because it happens here and here. We can really see that. When your discriminant is 0, there is one real zero. It only touches this line once. Again, because the square root of 0 is just 0. Now what happens when it's negative? Square root of a negative doesn't work. That's not a real thing. So we say there's no real zeros. You can see on this line, it doesn't touch at all. This parabola has no x-intercepts. So there are no real zeros. Now in the future, we're going to go through and figure out that there's actually two imaginary zeros, two complex numbers, where it does actually, quote-unquote, touch this line. Now again, really, looking at this parabola, it does not, but it's not real zeros, it's imaginary. And we'll go over that in future videos. But so the discriminant, just this chunk, the b squared minus 4ac, if it's positive, there are two real zeros, two spots where it touches the line. If it's 0, it'll come down and touch it just at one spot. If it's negative, it'll never touch this line. So, for example, if they were to ask you, how many zeros does each function have? So again, this is like saying, how many x-intercepts does each function have? So looking at this, how many x-intercepts does this have? Not necessarily super easy to tell just by looking at it, but b squared minus 4ac, we're going to use the discriminant. Negative 8 squared minus 4 times 2 times 7. Negative 8 squared is 64. 4 times 2 times 7 is 56. 64 minus 56 is 8, and that's positive. Since it is positive, there are two real zeros. Let's check for this one. 2, 16, and 32. Negative b over 4ac. I'm going to move these down to separate things. B squared, 16 squared, minus 4 times a times c. 4 times 2 times 32. These ones are going to be big numbers. 16 squared is 256. 4 times 2 is 8. 8 times 32 is 256. 256 minus 256 is 0. So there's one real zero, right? The parabola will come and touch the x-intercept at one spot. Try this one. 3x squared minus 5x plus 11. We use the b squared minus 4ac. B is negative 5. Negative 5 squared minus 4 times a, which is 3, times c, which is 11. Negative 5 squared is just 25. 4 times 3 is 12, times 11 is 132. 25 minus 132 is negative 107. Square root of negative 107 doesn't work because it is a negative number, so we know there are no real zeros. It would come out imaginary. So that's how we would use our discriminant. So that'll be the end of our third video. We've discussed the quadratic formula. Now in another video, I'll show you where the quadratic formula comes from, but that'll be a bonus. So we've discussed using the quadratic formula, and we've discussed the discriminant, which again is a part of the quadratic formula.